In this example, we're going to determine the monthly payments on a loan. It is a credit card, but it's treated just like a loan. So we're going to use the same formula that we have from page 245 in our textbook. I've already identified those particular values that we need from the problem. So if you haven't already, pause to read it. Make sure that you agree with these values. I'm going to skip now ahead to the part where we substitute these values into the formula. So I've just taken those values, substitute them in this formula over here. And now I'm going to work through this with the order of operations. So what I'm doing is I'm looking for some of the innermost things to do first. That's what the order of operations tells us to do. And I see, let me put this in different color here. I see these expressions here inside parentheses that need to be completed first. And this 0.12 divided by 12 is the same as 0.01 when I calculate just that expression. So when I go back and rewrite PMT, I get 3,200 times 0.01. That's evaluating that one expression. The nice thing is I see that same expression here in the denominator, 1 plus, and then we've already evaluated this expression. So I know that its value is 0.01. Another thing I can go ahead and take care of, because it's kind of in a parentheses by itself, is this exponent. Negative 12 times 1 is negative 12. So that will be the exponent here in that for that part of the expression. So up next, I still see that there's some things to do inside parentheses, and that would be this piece. So 1 plus 0.01 would be 1.01. And just to save a little bit of space, I'm going to move this and evaluate it in that spot. So that was, again, 1.01 raised to the negative 12. So that still stays there. Okay, so after this, now I'm looking to see what else can I do inside parentheses. Now you might say, well, there's nothing else to do inside the parentheses, but there's technically some understood parentheses here. There's an understood set of parentheses around the numerator and one around the denominator. So really we should go through and evaluate what we see in the numerator and denominator separately. And there's some things here in the numerator I could do first. 3,200 times 0.01 is 32. So that expression in the numerator becomes 32 when I evaluate it. And in the denominator, when I look to see what can I do within the denominator, the exponent takes priority over the subtraction here. So let's evaluate that exponent. And when I do that, I do get a long decimal or string here, and I'm going to write out as much as I can in this space. So the idea is that I want to keep as much accuracy within the problem and then round at the very end. So I'm going to try to keep several of those decimals there that I got when I evaluated 1.01 raised to the negative 12 power. So the last thing I see that needs to be done is the subtraction, because remember, there's still an understood set of parentheses around this denominator. So we will subtract, and I get 0.11. Again, I'm trying to just keep as many decimals here as possible. I'm writing down several from my calculator, but there's even a few more on my calculator. So then the very last step I should do is 32 divided by that decimal number. And when I do that and I round, at this point I could round to the nearest cent, I should get $284.32. So the next part of this asks, when the card is paid off, how much will you have paid since January 1st? Well, these are your monthly payments, and you're paying them for a total of 1 year, so that's 12 payments. So let's take this value and multiply by 12. We get payments times 12. That's the number of payments. We have $3,411.84. To then determine what percentage of the total payment from Part B is interest, we first need to decide how much is interest. So we'll take this and subtract $3,200. That's the amount of the principal. We get $211.84. Divide that by how much was paid, which was the $34.11.84. And then express that as a percent. I believe in the instruction it'll say round to the nearest tenth. So as a percent, that should be 6.2%. So remember, your calculator is going to give you a decimal. Change that to a percent. Now, of all the parts in this problem, maybe the one thing people I see get most hung up on is the very first part, because that formula is very massive, and there's lots of pieces going on there, even in the order of operations. So what I'm going to show next is Part A again, but with the TI-84 calculator. And I'm going to take advantage of the calculator's fraction abilities using alpha y equals enter. That's a shortcut for the fraction template. And let's type here 3,200. There was a set of parentheses. There is another fraction, so I can do another template, fraction template. Use the arrows to move from numerator to denominator or out of the fraction. I use the right arrow to move to the denominator. Let's see, 1 plus, here's another fraction. So alpha y equals enter gives me another fraction template. And then that is raised to the negative 12, hang on, negative 12, I was typing the minus sign, that is a difference there, times 1. I guess I really didn't need that, but that's a quicker way to get to that payment amount. And I really like that feature. It gives us the chance to really compare from the way we write it, the way the formula is written, to the way the calculator has it.